Welcome to this class on AWS IAM Roles Anywhere. Now, this is going to be a small class, but it's going to be a high impact class because it's going to acquaint you with a very specific area of the IAM that's been launched more recently with AWS. This is called Roles Anywhere. The idea here is that even if you have resources and services running on non-AWS environments like your private cloud or any other cloud provider, you should be able to securely integrate it with an AWS service. And that's something that we're going to be focusing on IAM roles anywhere. As always, we're going to start off with a little bit of theory, which is going to end with a very detailed lab on how you can run IAM roles anywhere in a way that is more secure and more scalable for your organization. So I'm really excited for this class. Let's get started. Now let's look at the learning objectives for this very focused class we have on AppSecEngineer. Now this class, as you can probably imagine, and as the name suggests, is very specific to IAM roles anywhere, which means we'll be only exploring this concept. And of course, we'll be looking at a counterpoint to this particular concept. Now, the first thing we'll start off with is understanding something that I call the persistent credential problem. Now, the persistent credential problem essentially is an issue where you have these credentials that you've created for users, and these credentials are non-AWS resources or even in AWS resources. And these credentials happen to be long-lived and they don't ever time out or expire in any way, which way, shape, or form. Now, this is a problem because when you have persistent credentials, any compromise of those credentials, first of all, you may not even know that they're compromised. The second thing, you might have a scenario where the compromise happens, you don't know about it, and they could be used extensively for a long period of time to be able to compromise, gain access to sensitive data or to delete resources or do a whole bunch of things. So persistent credentials are generally problematic, and we want to explore something that can help address this problem, which is our solution, which is IAM Roles Anywhere. IAM Roles Anywhere is going to be the solution that we're going to use, especially for non-AWS resources to access AWS resources. So let's say I have a on-prem deployment. This on-prem service needs to talk to S3, or this on-prem service needs to talk to DynamoDB or some other AWS service. How does it do that safely, securely, in a way that solves the persistent credential problem? That's going to be IAM Roles Anywhere. And in typical AppSecEngineer style, we are going to do labs for this. We're going to look at a lab which is going to comprehensively take you through IAM Roles Anywhere and help you work with an application that works with IAM Roles Anywhere. So this is going to be a really fun class, a very short but focused class on IAM Roles Anywhere. I'm really looking forward. Let's get started. As always, let's start with an example because examples are always a good way for us to learn things. Now let's take an example of this. So let's say I have two services or two applications. In this case, I have a Node.js application and I have a Python application. The Node.js application happens to be running on-prem and the Python application happens to be running on some other cloud. It could be Google Cloud, it could be Azure, it could be what have you. It could be running on some other third-party cloud, DigitalOcean, whatever, right? Now, the problem here is that this needs to talk to an AWS resource. So let's say they need to talk to DynamoDB. Now, DynamoDB, as many of you know, is one of the managed databases in AWS, and it's a very convenient database to use, especially for NoSQL use cases. So for instance, I'm a big fan and I'm a big user of DynamoDB myself. So these two applications need to talk to DynamoDB. Now, the thing with these applications is that they will need IAM policies and capabilities to be able to talk to DynamoDB. They just can't talk to DynamoDB on a port. It just doesn't work like that. You need to have IAM privileges to be able to get item, put item, scan, do whatever DynamoDB operations you have. DynamoDB has a whole bunch of actions and operations. So that's what you would need to do in order for these two applications to start talking to DynamoDB. However, there's a problem, right? So how do you do that? Now, the most common approach that a lot of people end up using is using credential. What they do is they create a user called Node.js user, and that user has some credentials that are generated. And those credentials essentially injected into the app that has Node.js. So that basically is injected into the Node.js application environment. So let's say this is running on a server somewhere. These credentials are injected into that Node.js app. And that's where the Node.js app is able to access. Using those credentials, the Node.js app is able to access DynamoDB. And of course, the same thing happens with the Python application as well. It also has credentials. They probably create an IAM user called Python app. And this you can use to generate the AWS access key ID and secret. And they use that access key ID and secret to be able to talk to DynamoDB because they have a policy that is scoped to DynamoDB and is able to talk to DynamoDB. Now, this is a perfectly valid way of doing this. However, it's not a very secure way of doing this because you have persistent credentials. Now, persistent credentials, as the name suggests, is persistent because you typically have users. So, for instance, in IAM, you have users in groups. What most of us would do is create a user account. So, in this case, they would treat it as a human user and say, I have a human user named Python app or Node.js app. You generate credentials for that, use those credentials inside the server or inject it as environment variables inside a container or whatever it is, and then use those credentials to be able to access DynamoDB. So they would use user accounts over roles, and this is inherently a problem. Now, roles essentially are meant for service to service kind of communication. That's better than using user accounts. So that is, first of all, that's what happens. So the next thing they have is that these credentials are persistent credentials. Remember, you are generating an AWS access key ID and secret for both sets of applications. So you have 4 credential elements. You have the AWS access key ID and secret for the Node.js app. You have the AWS access key ID and secret for the Python app. And these are persistent credentials, which means that until you revoke these credentials end up being available all the time. Now, let's say somebody compromises that Node.js app or that Python app or whatever. They gain access to these credentials. Now they can use these credentials to be able to access DynamoDB just as the user would. So there's a huge problem with that simply because, first of all, you may not know that this has been compromised. The second thing is, since these credentials are persistent, they are allowed access persistently to that particular AWS environment. There's no other way of checking whether it is coming from the right source and all of that stuff. It becomes a problem. So ideally, you want credentials that expire. And AWS does allow you to do that with roles and permissions and assume role and so on. That is something that you should be using for credentials rather than using persistent credentials. So what we have done with our previous setup is a pretty big problem. The next thing is that we don't have any kind of trust. Now, one of the things you will realize with that previous example where you just have this Python app and we have this Node.js application is we are placing a huge amount of trust on those servers and those applications to not be compromised. And they have credentials and these big scope credentials, and these credentials have access to this DynamoDB database. So imagine that your production database. So you're placing a lot of trust on these applications. And that is something that is really dangerous because you don't really have a way to verify or authenticate the trust. You're just assuming that these applications are going to be secure, and as a result of which everything is going to be fine. And that's a problem. Now, let's essentially understand what IAM Roles Anywhere is all about. Now, here you are essentially having the same example where you have a Node.js application on-prem that needs to talk to a DynamoDB database table that is on Amazon. That's obviously on Amazon. Now, the idea here is that instead of using these persistent credentials that may be compromised at any given point in time, and of course, since they're persistent, those credentials make it easy for someone to continue to keep that compromise going and keep that persistent state of attack going. So that is the problem. So IAM Roles Anywhere is a solution that allows you to create temporary credentials based on IAM roles. Now, this is possible with a whole bunch of different moving parts, and we will go over the moving parts one by one in this particular course before we get into a lab and you actually see this all put together and working as a real world example. So we'll see exactly how this is going to work in this segment, which is going to be looking at IAM Roles Anywhere in detail. So the idea here is that we want to be able to use IAM Roles Anywhere, which means that we want to, first of all, use roles instead of users. So we want to create roles, attach them to policies, and that role is something that this resource, so in this case, our Node.js application hosted on-prem, should be able to assume, just like an EC2 server inside Amazon is able to assume a role to access S3, this particular non-AWS resource should be able to assume this role that is attached to a particular policy, and this attached policy should give this assumed access to that particular credential, or to give you that particular credential to be able to access a database and so on and so forth. So in this case, it is DynamoDB, it could be S3, or it could be whatever else it is in a different scenario. So let's start with the steps that happen in IAM Assume Roles. So these are the steps that you need to set up for you to be able to successfully do an AWS IAM Roles Anywhere implementation. Let's start with the first one, which is creating a trust anchor. Now, a trust anchor is something that you need. That is like the first thing that you need for setting up IAM roles anywhere. Now, why is this necessary? Now, remember, one of the points that we mentioned before is that we have this implicit trust on this particular component, like this Node.js application, that, hey, the credentials are going to be safe. Now, the problem there is that this implicit trust needs to be done away with. So one of the ways AWS has devised a way to do away with this implicit trust issue that we have is to use public key infrastructure, or basically use certificate authorities. So in this case, what we are going to be doing to start off with is setting up our own certificate authority. Now, this can be done in AWS using AWS Private CA, or we can set up our own third-party certificate authority in Vault or OpenSSL or something like that, and use that as the trust anchor. So the idea here is that you can use either AWS's Private CA, which is the easier, the more path of least resistance style solution. But remember, AWS Private CA is going to cost you about $400 per month to use. So it's pretty expensive as a service to be able to use. So I would not recommend it unless you have a real production use case and you want to use only AWS and you have to use it from that standpoint. Then use it by all means, and you're okay with the $400 cost, then that's fine. But what we are going to do is use the more tougher way of doing this, which is going to be using OpenSSL to create our own private certificate authority. Now, what we are going to do is upload that certificate bundle to AWS so that AWS has this trust anchor. Now, the idea here later on is going to be that we're going to issue certificates for each and every component. So we're going to issue a certificate for the Node.js application. We're going to issue another certificate for the Python application using this certificate authority. And since AWS has the certification bundle, it should be able to verify that it has been signed with the right key, and it should be able to verify that certificate before allowing that resource access to assume that role and be able to actually do whatever it does in order to access an AWS service. First things first, we are going to create a trust anchor. So this is something that we're going to start with doing. The next step that we're going to do is we are going to create a role, a policy, and a profile and assume role capabilities in AWS. Now, this is where we're going to be using AWS IAM as before to create a whole bunch of resources like a role, a policy, a profile, and an assume role capability that we can use to actually have this non-AWS resource assume a particular role, which is attached to a policy and profile that they can use to access an AWS resource. It could be an S3 bucket, it could be DynamoDB, so on and so forth. So let's see how that works. So the first thing we're going to do is we are going to create a role. So we're going to create a role. Now, this is basically our role definition where we're declaring that this is the principal that is allowed to assume this particular role. So we're saying that, hey, this principal, in this case, it happens to be rolesanywhere.amazonaws.com. So that's the principal. And it is allowed to use the security token service of AWS to assume a role, to create a tag a session, to create a source identity, all of that stuff. And if you notice, there's another additional condition to this particular role statement, which says that if the certificate has a common name of node-js-app, only then that resource is allowed to assume this particular role. So this is the role that is assumed by the non-AWS resource to access a particular AWS service or AWS resource. And this is done using a roles anywhere principle. The actions require you to have the assume role tag session set source identity, which allows you to actually create a session, start that session, tag that session. And of course, remember, it can only happen when the common name issued by that certificate authority that we saw is going to have Node.js app. So it could be any other common name. So let's say you are using some other app like Ruby app or whatever it is, you can call it Ruby app or any other name that you want. But the common name of the certificate that is being used by this app to get those credentials, those temporary credentials, needs to be this. Whatever is declared here needs to be the same common name in that certificate. So that is the first thing we're going to do, which is create that assume role. Then we are going to create a policy. Now, this is the policy that you need for that role to be assumed. And end of the day, a policy is what you need for that resource to access this AWS resource. In our case, we want to be able to access a DynamoDB table. So in this case, you will say that, hey, allow someone this particular role to access this ARN of the DynamoDB table. And the actions can be 3 actions. It's only allowed to do 3 actions on this DynamoDB table, which is get item, put item, and scan. Nothing more is allowed for this particular Node.js application to be able to be done against this particular resource, which is the DynamoDB table. So it's a pretty tightly scoped policy, as you can see, which is really good. This is the second part of what we're going to have to do. So first the assume role, then we're creating the policy, and finally we create a profile. So basically a profile is where you are going to define a set of permissions that you can apply to a role. And that is something that you need to use for roles anywhere. So you're defining a predefined set of permissions that you're applying to that particular role. Now you can add additional conditions like IP address or any other type of condition that you want to add, let's say a time-based permission, an IP-based permission, in order to further restrict access based on that profile. But a profile is what you need in order to actually finish your IAM roles anywhere definition. So remember, so far, we've gone over a whole bunch of things. We've looked at trust anchor. We have looked at creating a role, an assume role, and a profile to be used along with that non-AWS resource. And finally, we're creating a profile. And this is what we're going to be using in our next step, which is going to create our certificate for that resource and then start using that non-AWS resource to be able to talk to AWS related services. So let's look at that in our next video. Now, so far we've looked at step 1 and 2, which is basically create a trust anchor and create the roles on AWS to be able to facilitate IAM roles anywhere. Now, this is the steps that you need to do on the AWS side of the fence, which is your pre-setup stuff that you need to do to set up AWS to make sure that IAM roles anywhere works with AWS. However, the next 2 steps that we're going to be looking at needs to be done for the client. So in this case, our Node.js application. The first thing that we need to do here on the client side of the fence is step 3, which is generate a certificate for that Node.js application. So this is the step that we need to be focused on, because now remember, we have a certificate authority that we've set up as the trust anchor. That trust anchor has been registered with AWS. And let's say you're using AWS private CA, then you don't even need an external trust anchor to be uploaded or anything like that. It automatically creates that certificate bundle. Now you can just use that to issue a certificate for whichever resource that you want to do. So in this case, since we are not using AWS private CA, we are going to be using our OpenSSL private CA that we've set up to be able to generate a new certificate for the Node.js application. Our application is a Node.js application. We're going to create a certificate. Now, this certificate is first going to be verified by the AWS control plane just to make sure that it is actually being verified against the trust anchor that is there. And then the access is validated based on that particular, the common name that is there and the policy it's allowed to define and so on and so forth. And once that is done, it's allowed to access that resource and get the credentials to be able to access DynamoDB or S3 or whatever it's scoped to access. So the step 3 is for us to generate a certificate for that non-AWS resource that is going to access an AWS service. Now let's look at our next step, which is going to be the most important step, which is generating our credentials. This is the step that you need for actually generating those credentials that you need to access those AWS services that you want. Now, the last step is going to be basically us using an AWS signing helper to generate a whole bunch of different parameters to generate these credentials. Now, remember, these credentials are just like any other assumed role credentials, which is that they are short-lived. They're not persistent credentials. So they're short-lived credentials and they're not persistent credentials. So even worst case, these credentials are compromised. they are compromised to a certain extent and they're not compromised forever. So that is something that you should keep in mind. AWS provides a CLI tool called the AWS Signing Helper. And you need to pass a certain number of parameters, and the AWS Signing Helper talks to the AWS control plane, talks to the security token service, make sure that the certificate is valid, the role is valid, the policy is valid, the trust anchor is valid. All of the validity is verified, and it generates temporary AWS credentials, which happens to be the access key ID, the secret, and the session token to be able to actually use these credentials. So the AWS signing helper is a pretty simple CLI. All you have to do is call the AWS signing helper, pass the certificate of in this case, the certificate and private key is going to be of the Node.js application that we have. You need to use the trust anchor ARN. Remember, we loaded with the AWS control plane with our trust anchor certificate bundle. So that creates an ARN by itself. We need the trust anchor ARN, the profile. You remember we created the role profile for our IAM Roles Anywhere deployment. You need that profile ARN to be referred to, and the role that this particular resource is going to try and assume. That role is required. Now, all of these things are required. And when you pass all of this, AWS validates all of this, make sure that it's actually valid, and it spits back a bunch of valid credentials that you can use to access that particular AWS resource for a certain period of time. I think the default time is 12 hours, but you can use the profile and things like that to cut the time down even a little shorter if you need to do it. That is something that you're doing. So this is the final stage of the process. So at this stage, you are really using this AWS signing helper multiple times or as many times as you need to generate credentials and use those credentials in actually talking to your AWS specific service inside AWS. So this is how you are generating those non-persistent credentials to be able to talk from a non-AWS resource to be able to talk to an AWS resource in a much more secure and anchored way. So that's one of the things that you'll see. Since it's based on a trust anchor, you're using PKI to be able to generate these particular credentials, which is a lot more scalable and secure rather than what it used to be, which is basically just inject credentials, which is persistent and never expires. This is how it works with IAM Roles Anywhere. And as always, our next step is going to be looking at a lab where they're going to be putting all these pieces together in a hands-on environment and deploying it on AWS. And of course, you're going to be using a on-prem Node.js application and then connecting that to a DynamoDB to be able to talk to DynamoDB to store, process, and delete some records on DynamoDB. So this is going to be our lab. I'm really looking forward to our lab. Let's get started. So finally, it's time for our lab. And this lab is something that is based on our example that we've been talking about so far. So what we're going to do is we're going to deploy a Node.js application on our lab machine. And this lab machine is obviously something that you have as part of your AppSecEngineer subscription, so you can access your lab machine. And we are going to first generate a trust anchor and load it into our AWS account. Now, this trust anchor is not going to be using AWS Private CA. You don't want to pay $400 a month for that. What we're going to be using is OpenSSL. Now, OpenSSL is a super convenient and super versatile library that you can use to be able to actually generate private public key pairs and so on and so forth, but also use it as a private CA. Now, I recommend using something more robust like Vault if you want to do this in a little bit more production-like state. Or if you really want to do this with AWS walled garden approach, then just use AWS Private CA. But remember, there is a cost to that. So we're going to generate our trust anchor. We're going to create our roles. All of this is going to be done using Terraform. And once we're done with creating our roles, the policies, the profiles, and so on, we're going to generate a certificate for our Node.js app. Once we generate the certificate for our Node.js application, that certificate is what we're going to be using in order to access AWS control plane to be able to generate those temporary credentials. Remember, I spoke about the AWS signing helper. We're going to be using the AWS signing helper, pass in our certificate, our key, our profile, our role, our trust anchor AR and all of that stuff in order to be able to generate some credentials. Now we're going to use these credentials in order to talk to DynamoDB. And once we talk to DynamoDB, you will see that our Node.js application is going to be able to seamlessly be able to store, process, and do whatever it needs to do with DynamoDB, which is get item, put item, delete item, scan item, whatever it is. I talk to the database like any other application, as if that application were hosted in AWS itself. So that is going to be the focus of this particular lab. This is going to be a lab with quite a few moving steps, so make sure you follow the instructions carefully, and I'll lead you to it. I'm really looking forward to seeing how all of you enjoyed this lab. Let's get started with our lab. Now, if you're watching this lab, this is going to be a lab that we are going to be using for IAM Roles Anywhere. Now, if you're watching this on YouTube, you will not have access to this lab because this is on the AppSecEngineer platform. And if you'd like a subscription to AppSecEngineer, you'll have to get a subscription. And with that subscription, you will be able to access this lab and actually run IAM Roles Anywhere for yourself. But if you're watching this on YouTube, you can probably use some of the concepts of the lab to set it up by yourself and then figure it out. So this lab is going to basically be on our AppSecEngineer platform, as I mentioned, and it has all the details, all the dependencies, all the code that you need to actually run this lab, right? So this lab is essentially going to be us deploying a Node.js application on a server somewhere. In our case, it's going to be a Google Cloud server. And we're going to use IAM Roles Anywhere to provide some privileges to this non-AWS resource. Remember, it's a non-AWS resource, and this is going to be available. So this non-AWS resource is going to be able to access DynamoDB inside an AWS account. And through this, it's going to be able to make, get, post, whatever calls it needs to do to DynamoDB to store, process, read, write, delete data, right? That's what it's going to do. So that's what this Node.js app is all about. And I'll explain how this works. So I'm going to first provision the lab on AppSecEngineer, and this is simple enough. This should take about anywhere between 30 to 60 seconds. Provisioning the lab. Now, this is a sandbox lab. So if you're a Business Plus customer of AppSecEngineer, you get a full AWS account sandboxed for you to use as well. So that's pretty powerful stuff. That you don't have to even have your own AWS account. So the lab is provisioned. It was super quick. So let's get started by accessing this lab. So when I click access, I get access to the lab environment, and this lab environment is basically like our IDE, right? So if you're used to Visual Studio Code, you'll know this lab environment. Now let's get started with the actual instruction. So first of all of our code is in here. IAM Roles Anywhere. We have our app. We have the Terraform files that we're going to be using to create the trust anchor, and the DynamoDB setup, and all of that stuff is going to be here. Our root CA is going to be in here. So all of that information is here. The cert files are going to be basically some configurations that we need to generate a certificate authority. And of course, we have our Node.js application that we are going to be using to actually connect to DynamoDB as a non-AWS resource using IAM Roles Anywhere. So let's access a terminal and actually get started. So I'm going to first generate a certificate authority. So the certificate authority, we're going to be using OpenSSL. Now you can use Amazon Private CA, but obviously, as I mentioned before, Private CA costs you $400 a month. So we're definitely not going to pay $400 a month. We are going to use OpenSSL, which is free. So free is very nice. It's very difficult to not want free. So we're going to use OpenSSL to generate a certificate authority. This is going to generate all of the dependencies that we need to generate our certificate authority and all the credentials and keys that we need to be able to sign certificates to behave as the trust anchor. So this is what we're going to be using as the trust anchor, mind you. So all of this stuff is what we're going to be using as the trust anchor. Now, since I'm using a Business Plus account, I'm going to just set up the AppSecEngineer sandbox AWS environment, and this gives me a real world AWS environment where I can run my payloads. Really, really useful, especially if you're a business plus customer of AppSecEngineer. Now, we are going to now start to deploy our infrastructure as code. In fact, let me move this to AWS creds to, I think that should be good. All right. So now let's do Terraform init. So Terraform, all the necessary providers that are required for us to work with Terraform come up. Remember, Terraform has a whole bunch of different providers that we're using. We're using AWS, we're using random. These are the two providers. It downloads the latest providers. And of course, we're going to be using these providers to create our role, to create our DynamoDB table, to generate some outputs for us to use along with our application, our provider information, our trust anchor information. Remember, we need a trust anchor with our certification bundle. So this is all in here. So this is kind of already done for you, right? So let's go ahead and do Terraform apply. And I'm going to use auto approve because auto approve because I know that this works reliably well. So that's the reason why I'm not going to be. Usually you should do Terraform plan and then do Terraform apply and then approve it manually. But if you're doing it in an automated way, or if you're pretty sure of how it's going to go, which in this case I am, I'm going to just go ahead and do it. So you'll see that it created all the necessary resources on Amazon for this to work. So if you actually go ahead and see, I'm going to log into the AWS account, and you will see that this is the sandbox AWS account that was generated from AppSecEngineer, by the way. So you will see that once I access this, you will see that a whole bunch of things have been created for me. So you'll see DynamoDB, for instance, created. So DynamoDB, you will see DynamoDB created, and you'll see the tables, you'll see that. Yeah. So it actually created. All this was done by our Terraform scripts, right? So if you go into the IAM roles and things like that, you'll actually see our role showing up as well. So all of this is created on AWS by our Terraform. So let's see what our role is called. So roles anywhere. Let's look for this, and you should see that creates this IAM roles anywhere, blah, blah, blah. You're not allowed to do all of this stuff, but nevertheless, it has created it. So don't worry about it. Fair enough. Now we already have all this done. We have done our deployment, DynamoDB setup. Now let's use our signing helper to generate some credentials for us. So this is going to be where we're going to say, hey, AWS signing helper, please generate using our private key and the certificate and our trust anchor ARN, which was generated. Remember, it was generated because we pushed our public CS public key to AWS as a trust anchor. This is the profile, this is the role, this is all of that information. So once we do this, you will see that it generates some credentials for us as part of this. So you see that it comes back with valid credentials. So this is our role that is assumed, and we have the ability to create these credentials. So now let us actually export AWS access key ID with this. Export AWS secret access key. And we have our secret access key as well. And finally, we need our session token. Remember, since we are assuming a role, the role requires us to have a session token. We're not using a user account like we would normally have done, right? So that makes it better. And this is not a long-lived. So you'll see that there is actually a expiration here. You'll see that the credential expires at a particular time, right? So this is the important part of using roles anywhere, because the credential is not a long-lived credential. So that's the big difference. That makes all the difference. Now let's run our Node.js app, right? So let's run our Node.js app. We're gonna install some dependencies to run our Node.js app. Remember, this is a non-AWS resource that we are running our Node.js app on. So that's what's happening here. And once we are done, we are going to access this Node.js app. So we'll say npm start. This spins up our Node.js app on port 3030, right? So if I go and access HTTP port 3030, you will see some application. So this looks like some employee management application. So let's add some employee data. The idea here is that this app is running somewhere on the internet, maybe in Google or DigitalOcean or wherever, even on-prem, for instance. And because of the IAM roles anywhere and the trust anchor setup that we have, this is going to be able to store and process all the data from DynamoDB. So I'll say, hi at test.com. So I'm just going to give some address. So I'm just going to give a phone number and I'm going to add this. So you see that this is done. And now if we go to our DynamoDB, surely enough, you will see that our DynamoDB setup is, you'll see that the data should be there. Okay. Not sure why it's not showing up. I don't think we have list privileges. Okay. I think we're accessing it with, I think Northern Virginia. So we need to be in Oregon for DynamoDB access, by the way. So it's only in US West 2 that you can access. Everything else is cut off for us. So now if you look at the table items, you will see that, yes, as we thought, it's there. So you can actually do this. You can create another employee. Right? So you're creating something. So when you're doing this, you will see that it's done. So it's actually, this application is not on our AWS. So it's not a Lambda or an EC2 or whatever it is. It's running completely somewhere else. And because it has IAM roles and roles anywhere, it's able to perform these operations like as if it were an AWS resource. And the better thing about this is, since it's using roles, it's not a long-lived credential. That makes all the difference when it comes to IAM roles anywhere. So I hope you enjoyed this demo. Thank you so much.